Let's now look at this particular question on the trigonometric identities. This is the question that the internal candidates for 2023 wrote. This is the 2023 ECZ or internal paper that was written in 2023, and this is question number 6 under additional mathematics under trigonometric identities. Let's see how we get. Prove that 2 over cos to the 4th power theta minus sine to the 4th power theta plus 1 is actually identical to secant squared theta. Let's see how we go about this particular question. Remember, we need to prove that what is on the left hand side is actually identical to the right hand side. So how do you go about it? So we see that here we are going to take the left hand side to be worked on. Let's see how we get started. So here we know to say the left hand side is actually equal to 2 over cos to the power 4 theta minus sine to the power 4 theta plus 1. So working this one out, we see here that we're going to have, this can be rewritten as 2 over cos to the power of 4 theta can be broken down, and this will be cos squared theta times cos squared theta. Then you put in the parenthesis. Then we're going to further say minus sine to the 4th power, we leave it deliberately here, theta 1. Let's see what happens. This we further simplify. We're going to have 2 all over out of cos squared theta. From the trigonometric identities, we know it is 1 minus sine squared theta. Take note. Cos squared theta is equal to 1 minus sine squared. We have 2 of these, so we can simply square this. Since you have 2 of these, we're going to have this, which is 1 minus sine squared theta, 2 of them. So we say 1 minus sine squared theta squared, and we say minus sine to the power of 4 theta plus 1. We further simplify this. If you do so, we're going to have 2 all over 1 minus sine squared theta to the 2nd power. This is the binomial. So the 1 will be raised to the 2nd power, and this will simply be 1. Then 2 will multiply by everything, so it will be 2 by 1, which is 2 times negative sine squared theta, and this will be minus 2 sine squared theta. At the end of the day, the minus sine squared theta will be squared, so negative squared plus, then we have sine squared theta times sine squared theta is sine to the 4th power theta. Then we bring down the minus sine to the power 4 theta plus 1. This is what you do. At the end of the day, you simplify further, and then you have, this is 2 everything all over. Now remember, it's important to note that here we have got like terms, so the like terms will cancel out. Take note, the like terms will cancel out. And in the case of this one, we see that we have positive sine to the power 4 theta minus sine to the power 4 theta. So this will cancel out. So that if this cancels out, then we're going to have, then we'll have this 1 here together with this 1 to make 2. So it will be 1 plus 1. So we're going to have a 2 here. So we write the 2, but we have minus 2 sine squared theta. Then we go further and try to factorize the denominator. We see that a 2 is common between 2 and minus 2 sine squared theta. So we take out the 2. So 2 will be out. Then 2 into 2 is 1. 2 into minus 2 sine squared theta will be simply sine squared theta. And this is what we have. At the end of the day, we know to say we have got a 2 in our numerator and we have a 2 also down here in the denominator. So 2 into 2, we know here to say this will be as follows. So we're going to have 2 into 2 is 1 all over. 2 into this 2 here is also 1. 1 times this, we have 1 minus sine squared theta. But we know here to say 1 all over 1 minus sine squared theta is actually cos squared theta from the trigonometric identities, if you can remember. Let me take you back. If you have cos squared theta plus sine squared theta, this will give you 1. This is from the trigonometric identity. It's one of the trigonometric identity. So it's, if you make cos squared theta the subject of the formula, will have 1 minus sine squared theta. Alternatively, if you make sine squared theta the subject of the formula, you'll have 1 minus cos squared theta. And this is what you have. No wonder where we see the 1 minus sine squared theta, we simply put cos squared theta. But we know here again to say from one of the trigonometric identities, we know here to say 1 over cos squared theta is actually equal to secant squared theta, which we know to say this is identical to what we have on the right hand side, and this is sec squared theta. So say hence proved. Here, yes, we see that what we have on the left hand side is actually, identical to what we have on the right hand side. And this is the solution. Thank you for watching.